All right, so named pipes or FIFOs can be created using the MK or make FIFO system call. And you can see it takes a path name and a mode. The path name is actually the location where you want to put a reference to the FIFO inside the file system. But just keep in mind it is not a real file, and I'll show an example later of what it looks like when you have a pipe or a named pipe in the file system. The mode parameter is kind of, let's say, unintuitively named. This is actually the permissions for the pipe file, basically saying who can access it. And so we usually just use in our like demonstration programs, we just say everybody can access it. So once a FIFO has been created and put into the file system, it can be opened from both sides using the open system call, where the path name will be the same as where the FIFO was created, and the flags say whether the application, the process, is opening the pipe to read or to write. Of course, you have to pick one because these FIFOs are, again, unidirectional. So a really important thing to note about FIFOs, these named pipes, is that the open system call is actually blocking. Basically, a FIFO can only be used once both sides have opened it, one for reading and one for writing. And so once a process opens a FIFO on one side, the process will actually block until another process comes and opens the other side of the FIFO. And of course, this is in addition to the fact that the reads and writes also sometimes block. So other than the kind of different creation and opening, these named pipes work just like anonymous pipes. And again, for what we call duplex communication, where you read and write back and forth between the two processes, you do need two FIFOs, and that'll be shown in the example. So the key point, of course, is that the FIFOs are persistent in some sense, not the data in the FIFO. That's still just stored in memory by the operating system, but the actual kind of object in some sense is persistent on the file system so that processes can use it anytime. You actually, if you want to get rid of the FIFO, you have to delete it yourself. Okay, so in this example, we have a client and a server, and you can see that these are unrelated processes. They're not related using fork or anything like that. The server, if you look on the right side, actually makes the FIFO, and you can see it makes two FIFOs, and 0777 basically just gives full permissions. And then after making the FIFO, it will open up both a read and write side. And the client also opens a read and write side. And notice the kind of order of read and write opens is alternating. So the client opens read write, and the server opens write read. And this is because we have to match the names in order. So both sides open the pipe server to client first, and then pipe client to server. So whenever you're opening multiple FIFOs, you have to match the order of the names. So from there, the program is kind of straightforward. It just basically, the client will send a sequence of integers over to the server. The server will read an integer. If it's 0, it'll exit. Otherwise, it'll send back the square. And this is just displaying another way that data can be read and written to pipes. And that's pretty much it for this one. Also, just remember the sample code. It's not displaying the like kind of full best practices like error checking. This is a very minimal example to demonstrate the use of pipes. So now here we can see an example output. So the two processes are actually being run manually at the same time. And actually, if you run this example code, you will note that once you open one of the processes, it will stop at one of the opening pipe lines until the other process opens up the pipe from the other side. Anyways, we see the intended behavior. The client sends some numbers, they get squared, it comes back, and the process is done.